Welcome to another thrilling journey into the cosmos. Today we're diving into a mystery that's baffling astronomers and lighting up the imaginations of space enthusiasts across the globe. We're talking about the discovery of a new odd radio circle, or ORC, near the center of our galaxy, a find that challenges what we thought we knew about the universe and opens up a whole new frontier of astronomical exploration. Let's start by setting the stage. Back in 2019, astronomers, using the Australian Square Kilometre Array Pathfinder telescope, or ASCAP, were conducting a routine survey of the sky when they stumbled upon something truly bizarre. They detected several rings of radio light. These rings weren't just unusual, they were completely unprecedented. Invisible at any other wavelength of light and with no obvious source, these rings didn't match anything that had been seen before. The astronomers who found them were so puzzled that they dubbed these phenomena odd radio circles, or ORCs. At first, only a handful of ORCs were known to exist, but their discovery sparked a wave of curiosity and speculation across the scientific community. What could these mysterious rings be? Where did they come from? And why were they only visible in radio wavelengths? The discovery of ORCs raised more questions than answers. Some astronomers speculated that these rings might be the remnants of massive explosions from distant galaxies, possibly the result of starbursts that produce a sudden influx of supernovae, or perhaps even the merger of supermassive black holes. Others wondered if these rings could be related to some unknown and exotic astrophysical process happening at the edge of the observable universe. However, all of the ORCs discovered until recently shared one thing in common. They were found at high galactic latitudes. This means they were far above or below the plane of the Milky Way galaxy, suggesting that they were either very close to us or far beyond our galaxy in the vast expanse of intergalactic space. In other words, these ORCs seem to be either local phenomena within our own galaxy or distant objects beyond its borders. Then came a discovery that would upend everything we thought we knew about ORCs. Using the MeerKAT radio telescope in South Africa, a team of astronomers, led by Cristobal Bordiu from Catania Observatory in Italy, discovered a new ORC. This ORC, however, was unlike any that had been found before. It was located just 6 degrees above the plane of our galaxy, right in the thick of the Milky Way. From our point of view, and even more intriguingly, it appeared to be relatively close to the galactic center, which is about 26,000 light-years away from Earth. This new ORC, which has been catalogued as J1802-3353 and nicknamed Kýklos from the Greek word for circle, presents a significant puzzle. Unlike other ORCs, this one doesn't fit the existing models that have been used to explain these phenomena. Its proximity to the galactic plane suggests that it might not be extragalactic at all, but rather something within our own galaxy. But what could it be? Kýklos is an almost perfect circle, spanning 80 arcseconds in the sky, which translates to a physical size that depends on its distance from us. The ring is faint, patchy, and thin, just 6 arcseconds thick, and it exhibits a flat radio spectrum. This flat spectrum is unusual for ORCs and suggests that whatever is producing the radio waves in Kýklos isn't a typical radio source like those associated with other known ORCs. To understand what Kýklos might be, let's explore some of the possibilities. One hypothesis is that Kýklos could be a supernova remnant. When a massive star reaches the end of its life, it explodes in a supernova event, releasing a tremendous amount of energy. This explosion sends a shockwave through the surrounding space, creating a spherical shell of gas and dust known as a supernova remnant. These remnants often appear as circular structures when viewed in radio wavelengths. However, supernova remnants also produce X-rays, and so far no X-rays have been detected coming from Kýklos. This absence of X-rays is a significant challenge to the supernova remnant hypothesis. It suggests that if Kýklos is indeed a supernova remnant, it would have to be a very unusual one. Perhaps an old remnant where the X-ray emission has faded away, or a remnant that for some reason didn't produce X-rays in the first place. Another possibility is that Kýklos could be a planetary nebula. Planetary nebulas are the cast-off outer layers of dying stars that are similar in mass to our Sun, as these stars exhaust their nuclear fuel. They shed their outer layers, which expand into space, forming a glowing shell of gas that can be seen in visible light and sometimes in radio wavelengths. Planetary nebulas are typically a few light years across, and they often appear as round or oval shapes when observed from Earth. However, if Kýklos were a planetary nebula, it would be an exceptionally large one. To appear 80 arcseconds wide in the sky at a typical distance of a few thousand light years, Kýklos would have to be at least 10 light years across. This is much larger than most known planetary nebulas. Additionally, planetary nebulas usually emit light in specific wavelengths, such as hydrogen alpha light, yet no such emission has been detected from Kýklos, making this explanation less likely. One of the more intriguing possibilities is that Kýklos could be associated with a type of massive star known as a Wolf-Rayet. Star Wolf-Rayet. Stars are among the most massive and luminous stars in the universe, and they are characterized by strong stellar winds that blow away their outer layers. These winds create shells of gas and dust around the star, which can sometimes be seen as nebulae in various wavelengths. Wolf-Rayet stars are also known for having flat radio spectra similar to what has been observed in Kýklos. This makes the Wolf-Rayet star hypothesis particularly compelling. If Kýklos is indeed the remnant of a Wolf-Rayet star, it would suggest that the star has shed a significant portion of its mass, creating the circular shell we now see in radio waves. However, there are challenges to this hypothesis as well. For one, no Wolf-Rayet star has yet been identified within Kýklos. The nearest candidate is a bright star known as HD 164455, but it is not a Wolf-Rayet star itself. There are a few other stars within Kýklos that could potentially be the source, including a bluish star located 24,500 light-years away. If this star is the source of Kýklos, the ring would be about 10 light-years in diameter, making it a plausible candidate. Yet without spectral data on these stars, it's difficult to confirm whether any of them are indeed Wolf-Rayet stars. This is where future observations come in. The next step for astronomers will likely involve using the James Webb Space Telescope or other advanced instruments to obtain detailed spectral data on these stars and to search for any signs of a Wolf-Rayet star or other potential sources within Kýklos. But the mystery of Kýklos doesn't end there. There's also the question of what these ORCs can tell us about the larger processes at work in our galaxy and beyond. If Kýklos is indeed the remnant of a Wolf-Rayet star or some other massive stellar event, it could provide valuable insights into the life cycles of massive stars and the ways in which they interact with their surroundings. Understanding these processes is crucial for piecing together the broader puzzle of how galaxies evolve over time. Moreover, the discovery of Kýklos raises the tantalizing possibility that there are many more ORCs out there waiting to be found. The fact that Kýklos was discovered so close to the galactic plane suggests that there could be other ORCs hidden within the dense regions of our galaxy or in other galaxies that have yet to be observed. As astronomers continue to survey the sky with increasingly sensitive instruments, we may discover that ORCs are far more common than we previously thought. This would have significant implications for our understanding of the universe. ORCs could represent a new class of astronomical objects with properties that challenge existing theories about how stars and galaxies behave. They might also be linked to some of the most energetic and dramatic events in the cosmos, such as the formation of black holes or the collision of galaxies. As we look to the future, one of the most exciting prospects is the upcoming Square Kilometer Array, or SKA. The SKA will be the world's largest radio telescope, and it is expected to revolutionize our ability to observe the universe in radio wavelengths. With its unprecedented sensitivity and resolution, the SKA could help astronomers to detect even fainter and more distant ORCs, potentially revealing their true nature and origins. In addition to the SKA, other next-generation observatories, such as the James Webb Space Telescope, the Vera C. Rubin Observatory, and the Extremely Large Telescope, will play crucial roles in unraveling the mysteries of ORCs. These instruments will allow astronomers to study ORCs in greater detail across multiple wavelengths of light, from radio to infrared to optical. This multi-wavelength approach is key to understanding the full range of physical processes that might be involved in creating ORCs. But even as we look forward to these exciting developments, It's important to remember that science is a process of continuous discovery. Each new observation adds a piece to the puzzle, but it also raises new questions and challenges. Our assumptions, the discovery of Kýklos, is a perfect example of this. It reminds us that the universe is full of surprises and that there is always more to learn. So what can we take away from this story of mysterious radio circles and the quest to understand them? First and foremost, it highlights the power of curiosity and the importance of exploring the unknown. The astronomers who discovered Kýklos didn't set out looking for ORCs, but their willingness to follow the evidence and ask new questions has led to a breakthrough that could change the way we think about our galaxy and the universe. It also shows us the importance of collaboration in science. The discovery of Kýklos was made possible by the combined efforts of researchers and observatories around the world, working together to share data and ideas. This spirit of collaboration is essential as we tackle some of the most complex and challenging questions in astronomy.